Section 6.3 talks about confidence intervals for population proportions. It says in this section we're going to learn how to construct confidence intervals for population proportions, or probabilities of success, known as P. The process is similar to what we use to construct confidence intervals for means, and we're going to start with a point estimate as we did before. So the point estimate for P, which got it right here, the population proportion of successes is given by the proportion of successes in a sample and is denoted by, the way I read this little symbol here, guys, is P hat, because it looks like it's wearing a hat. And it says that right there, okay? Where X is the number of successes in a sample of size N, the point estimate for the population proportion of failures is known as Q hat, which is 1 minus P hat. So let's take a look at the first problem here, see if we can't figure this out. And it says, in a survey of 883 American adults, 380 said that their favorite sport is football. Find a point estimate for the population proportion of adults who say football is their favorite sport. Okay, so here is my formula for P hat. Okay, so let me write that down here. So P hat is equal to X divided by N. Okay, so N, remember, is our sample size. Sample size is going to refer to the number of adults that we surveyed. So we surveyed 883 adults. And X is the number of people who said that they liked, in this case, football. And in that case, we had 380. And so all we're going to do now is take our calculators here, guys. Let me turn this thing on. Let me clear my screen. And I'm just going to write this as a decimal. So we're going to take 380, and we're going to divide it by 883. And we're going to go ahead and just go to 2 decimals here, guys. So this is 0.43, okay? So 0.43 would be my P hat, okay? Just so that we understand, what does this mean? This means that 43% of the people who surveyed, who were surveyed, said that they liked football. So if I wanted to find, say, Q hat, okay? Remember what Q hat would be? It would be 1 minus P hat. So Q hat is going to be 1 minus 0.43. And so in this case, Q hat would be 0.57. And I want you to think about this in terms of percents, okay? Just for sort of like example purposes, 0.57 would be the same thing as 57%, right? So if you're watching the news at night and Tim Smith, gets after you because you don't know where Mission is on a map or whatever, but if he tells you something like, hey, there's a 43% chance that we're going to have rain today, okay? So if he says, hey, there's a 43% chance that it's going to rain, then that's the same thing as saying, well, then that means that there's a 57% chance that it's not going to rain, okay? All right. Take a look at number 2. It says, in a survey of 2,462 U.S. teachers, 123 of them said that all or almost all of the information they find using search engines online is accurate and trustworthy. Find a point estimate for the population proportion of U.S. teachers who say online information is accurate. Okay, so we're going to do the same thing we did before. We're going to look for our P hat. And our P hat is going to be defined by X over N. Remember, N is my sample size. So how many teachers did we survey? We surveyed 2,462 of them, and only 123 of them said that either all or almost all of the information they find using search engines online is accurate and trustworthy. Okay, so now what we're going to do, we're going to go ahead and do the same thing. We're going to take 123, and we're going to divide this by 2462. And again, as a decimal, if I'm going to change it, if I'm going to leave this as a decimal with 2 decimal places, I'd be coming up with 0.05, right? So then wouldn't Q hat be 0.95? Because it's 1 minus 0.05? All right. So now, we're going to talk a little bit about confidence intervals for population proportions. So it says, like we did for population means, we can construct a confidence interval for population proportions from a sample point estimate. We must first calculate the margin of error, E. Okay, so guys, remember how we were finding our confidence intervals? We were taking our average and we were subtracting the error, and then we're taking our average and we're adding the error, and we said our average is going to be somewhere between here. We're doing the same thing, except now we're doing it for proportions, okay? The part that is slightly different is the way we compute our error, okay? So my error formula says z of c times the square root of p hat q hat all over n. And so I'm going to write down that formula again because I'm probably going to need it as I go through. So the error is going to be my z score times p hat q hat all over n, and we're taking the square root of all that business right there. Okay. So let's take a look at problem number 3. It says construct a 95% confidence interval for the population proportion of Americans who say that football is their favorite sport. Okay, so first thing is we're going to find a 95% confidence interval. So again, the first thing I'm going to do, guys, I'm going to draw my picture because I want to get an understanding of what does this mean. 95% confidence interval means that the area between this value here and this value here is going to be 95%. So remember what that means. That means that there is going to be 5% left for those two pieces. So if I take 0.05 and I divide it by 2, that's going to give me 0.025. So the area here would be 0.025 and the area here would be 0.025. Okay? So what I'm trying to find those z values. Remember, this one would be negative and this one would be positive. So if I know that the area to the left here is 0.025, I can find this part by taking my calculator and clear this out. We're going to go second vars, and I'm going to go to inverse norm, okay? And I know that the area inside here was 0.025. Close that off. And so if you look at the z value I'm coming up with, to 2 decimal places, I would come up with negative 1.96, right? So this is negative 96. Let me fix that. 1.96, and then this one here is a positive 1.96, right? So the reason why I want to find this is if you look at my formula, I need to know that value. Okay, so let's start finding our error. I'm just going to write down the formula again so that I have it for this particular problem. Okay, square roots over everything. All right, so we just found our ZC value to be 1.96. Now, we're going to find our P hat and Q hat. So this was the problem talking about the football. So let me scroll back up because I know we found our P hat and our Q hat up here. Here we go. So our P hat was 0.43 and our Q hat was 0.57. So P hat was 0.43 and Q hat was 0.57. And remember, N is the number of adults that we surveyed. So let me scroll back up. How many adults did we survey? We surveyed 883. So I'm just going to scroll back down here. 883. And we're going to find our error. Okay. So guys, I'm going to do this on my calculator. Let me move this over a little bit. Clear this out. And I'm going to type it in exactly as I see it. So the first thing I see is 1.96. So 1.96. Okay. Times. Then I see a square root. So let's go second square root, and I'm going to type all this business in here. So we have a 0.43 times a 0.57. Oops, point, don't forget my point, I forgot it. Oops, point, there we go, 57, okay. Oops, I don't want to take my arrow, my parentheses off yet, guys, sorry about that. Let me delete that, there we go. Divided by, we're dividing the whole thing by, what is it, 883? Now I'm going to close my parentheses because that means that I'm taking the square root of the entire thing here, okay? And I'm going to hit enter and look at the error I'm coming up with. To 2 decimal places, I would say 0.03, right? Excuse me, 0.03. This is my error, okay? So now we're going to find our confidence interval. So I'm going to scroll back up here. Remember how we find our confidence interval? It's right here. We're going to take P hat minus the error, P hat plus the error. So let me do it here in red. P hat we said was 0.43 minus the error, which was 0.03, comma, 0.43 plus 0.03. And so that's going to give me, let's see, 0.43 minus 0.03 should give me 0.40. And 0.43 plus 0.40 or 0.03 is going to give me 0.46. And here is my confidence interval, okay? And it says the result is usually not stated as a confidence interval. Instead, the result would be stated something like 43% with a margin of error of 3.3%, okay? But this is how I'm going to be writing my answer in terms of a confidence interval, all right? So now let's do number 4. We'll go about it exactly the same way. It says construct a 90% confidence interval for the population proportion of U.S. teachers who say all or almost all of the information they find online is accurate and or trustworthy. Okay, so again, first thing I'm going to do, draw my picture. I think the picture helps out so much because it gives me a visual of what it is I'm looking for. What are we trying to find? A 90% confidence interval. What does that mean? That the area underneath these, and the area under the curve here, is 90%. So remember what that means. That means that there is 10% left for those two pieces. So if I take 10% and divide it by 2, the area over here is 0.05, and the area over here is 0.05. Now remember, whether I'm using my table, guys, or I'm using my calculator, we're always finding the area to the left. So I want to find these two z-values, okay? Remember, this one's going to be negative, that one's going to be positive. And we know that the area to the left of our curve is 0.05. So let me move this over here. Let me clear this out. And I'm going to go second in vars, go to inverse norm, hit enter, and I'm going to type in 0.05, close that off, hit enter, and I'm coming up with negative 1.64. So this is a negative 1.64. So this one here will be a positive 1.64, okay? So remember, my formula is going to be ZC times the square root of P hat, Q hat, all over N. Okay? We just found our ZC value to be 1.64. I'm going to do a big square root, and I'm going to come back up. I'm going to scroll back up here because we did this problem earlier. Here we go. Here was our P hat, and here was our Q hat. So P hat is 0.05. Q hat is 0.95. And then our N, there was a whole bunch of teachers that they surveyed. How many did they survey? 2462, right? 2,462. So let me scroll back down here and let me put this number in right there. Okay, so now we're going to find our error. I'm going to do this on my calculator again. I'm going to move it over a little bit because I got some room. Let me clear this out for y'all. And I'm going to enter it in again exactly as I see it. So I see 1.64 times second square root, right? And I'm going to type in what I see there. I see 0.05 times 0.95 divided by 2462. Close off my parentheses, hit enter, and I'm coming up with 0.007 is the number that I'm coming up with here. So 0.007, okay? Now, we're going to find our confidence interval. So our confidence interval is going to be P hat minus the error and P hat plus the error, okay? So we said our P hat was 0.05 minus 0.007, and then 0.05 plus 0.007. So we can do that on the calculator. So 0.05 minus 0.007. And so right here I'm coming up with 0.043. Right, that was the number we had there. And then if I'm going to add it, I'm just going to go second entry. And I'm going to change that minus right here, my friends, to a plus. And I'm going to hit enter and 0.057. And here's my confidence interval, okay? All right. So the next problem we have here says use the given confidence interval to find the margin of error and the sample proportion. So again, I want us to think about that sort of that number line, right? We're coming up with the two numbers we have is a 0.712 and a 0.740. So our p hat is going to be that number right there in the middle. So remember how we're going to find our p hat. We're going to find the average of these two numbers. So we're going to take 0.740, 0.712. We're going to add them together, and we'll divide by 2. So 0.740 plus 0.712 is 1.452. Now we'll divide that number by 2. And 0.726. So 0.726 is our p hat, right? Now we want to find the error. Remember, the error is going to be the distance either between those numbers. Between those numbers, it'll be the same thing, okay? So which ones do we want to find? It doesn't really make any difference. Let me take 0.740 minus 0.726. And so our error is 0.014. And here's our error. And then we said our p hat was 0.726. Okay? So I'm going to scroll down a little bit more. And it says, as before, one way to improve the precision of an estimate without decreasing the level of confidence is to increase the sample size. But how large a sample size is needed to guarantee a certain level of confidence for a given maximum error of estimate? So it says, given a C confidence level and a margin of error E, the minimum sample size N needed to estimate the population proportion P is given by, and we have a little formula here. It says N equals P hat times Q hat times the ZC divided by the error all squared. And it says, assuming that we have points for P hat and Q hat, otherwise we're going to use P hat being 0.05 and Q hat being 0.05 to ensure the larger sample size. So let's take a look at the problem that we have here and see if we can't figure this thing out. It says we're running a political campaign and we wish to estimate with a 95% confidence the proportion of registered voters who will vote for a candidate. Your estimate must be within 3% of the population proportion. Find the minimum sample size if A, no preliminary estimate is available, and B, if the preliminary estimate gives 0.30, or P hat being 0.31. Okay, so the first thing I'm going to do, I'm going to look at this formula. This is what we're going to use. So N equals, look at the first part. It says no preliminary estimates available. When no preliminary estimates available, these are the values we're going to use for our P hat, Q hat. So the first thing I'm going to do, I'm going to write down my formula. Okay. All right, and now let's see if we can go ahead and do the problem. So my P hat and Q hat, because I don't have a preliminary estimate, we're going to say 0.5 for P hat, 0.5 for Q hat. Oops, there was a square here, I forgot to write it. Times the ZC value for a 95% confidence level. So again, just to give you a basic picture of what's going on here, right? We want the area here, oops, inside that curve between those two numbers to be 0.95. Now I want to say we did that earlier today. So we did that right here. And we found our ZC value to be 1.96. So I'm just going to scroll back down here. And I know that this is a negative 1.96 and this is a positive 1.96. Okay, so I'm going to write right here 1.96. Okay, my error. Look what it tells me about the error. The estimate must be within 3%. Okay, That's my error. My error is 3%, and as a decimal, it's 0.03. And we're going to square this thing. Okay. So now we're going to find our value of n. Okay, so let me take my calculator. Okay, guys, remember this is what I have written down here. And I'm going to type it in exactly as I see it. So 0.5 times 0.5 times, now I'm going to open up parentheses, 1.96 divided by 0.03, close off those parentheses, and we got to square that whole deal. So I hit my little x squared button, and I'm going to hit enter, and I'm coming up with 1,067.11, whole bunch of 11s, 1,067.11, whole bunch of ones there. Now, the question then is, do I write 1,067 because I'm rounding to the nearest whole number? N is the number that we're going to need. So anytime we have anything after that decimal point, that means I need one more. Okay, so I'm not necessarily rounding to the nearest whole number, but we are rounding up. Okay. So my N here would be 1068. Okay. Anytime I have, in this particular problem, anytime I have anything after my decimal value, if I came up with exactly 1067 on the dot, that's what I would need. But if I have any decimal after that, I'm always going to be rounding up. Okay. Now, we're going to do the same problem because there's a little bit more. There's a part B to it. And part B says, well, what happens if our preliminary estimate gives us a p hat of 0.31? Okay, so I'm going to write down my formula again. P hat, Q hat, ZC, error, all squared. Okay, so we know our p hat in this case is a 0.31. Okay, now remember how I find Q hat? Q hat is 1 minus p hat. So let me take my calculator right here. Let me move this over, clear that out. What's 1 minus 0.31? 0.69. That's the next number I need. 0.69. Okay. Remember, this part here is going to stay the same as what we had here. This part didn't change. The only thing that changed was that business. So this is still 1.96. This is still 0.03, and it's still being squared. Okay. So let me take my calculator. I'm going to move it back this way so we have some room. Okay, and I'm going to type in exactly what I see. 0.31 times 0.69 times, I got parentheses, so I'm going to write them down. 1.96 divided by 0.03. Close it off. And don't forget to square it, and then hit enter. And I'm coming up with 913 and some change. 0.0 something or another, 3, something like that, right? 02, close it off. Remember, we're going to be rounding up. So then my number here would be 914. Okay, 914. And that right there, guys, is 6.3.